Okay, today's lesson's on 6.4, rational exponents. And so we have another way to write a radical expression is to use a rational exponent or a fraction. So when we have any kind of radical, for example, the square root of 25, that has an exponent form. Which it can be written as 25 to the 1/2 power. All right, if I have a cube root of 27, that would be 27 to the 1/3 power. If I have a fourth root of 16, that is 16 to the 1/4 power. Okay, so hopefully you're catching on that if it's a square root, my denominator is a 2. If it's a cube root, the denominator is a 3. And a fourth root, the denominator is a 4. Okay, so any base raised to the 1/n power, let's say, can be rewritten as the nth root of that base, a. So your denominator and your index will always match. All right, so that's the big takeaway there. Or we can also have it written as a to the m/n power, so there might not be a 1 in your numerator. N is still your radical index, and then you're raising it to the power of m. Or you can take the root first and then raise it to that power. Okay, so that's going to be your exponent or your power on top, and then n is going to be your index to the type of root. Okay, and then that's your other big piece. So that's really all that's going to be new in this lesson today, and then I'm going to show you ways that you're going to use that fact to simplify different problems. All right, so here's some examples. We might have to do some simplifying, like 256 to the 1/4 power. All right, so my denominator is a 4, so that means this can be rewritten as the fourth root of 256. If you know that one in your head just from practicing problems that we've been working on, you might know that is 4. You can also get there by doing some, you can go 16 times 16, doing some prime factorization, 4 times 4, 4 times 4, right? So you've got 4 to the 4th power gives you 256. That'd be another way to get there. Or you're testing things on your calculator. What to the 4th power would give me 256? Try some things. Okay. Number 2. For example here, so if I have negative 32 and I'm raising that to the 3/5 power, all right, I have a different way of rewriting that. I can write that as the 5th root of negative 32 to the 3rd power. That is the way I prefer to do it. Or you could do the 5th root of negative 32 to the 3rd power and then find that answer. So I'll show you both ways and I'll show you why I like the top example better. Here I'm taking the 5th root of negative 32. So what to the 5th power gives me negative 32? Well, that's negative 2. And then I'm raising that to the 3rd power to get negative 8. Okay, that's my preference because I can do all that in my head. Down here, if I do the cube, or if I cube it first, I'm gonna need a calculator. I don't know negative 32 to the 3rd power. All right, so then I pull up my calculator and I find out that that's going to be negative 32,768. All right, now what I did above with 256, didn't take me long to do a prime factorization. I don't want to do a prime factorization of negative 32,768. All right, that's going to take me a while. And I also don't know the fifth root of that in my head. Okay, so you can use your calculator. If you haven't realized that yet, you can do fifth roots and fourth roots and beyond. On your graphing calculator, you'll need to type in the number 5 for the index and then click that math button. And then you should see below, it's number 5, and it'll have x in front of that radical. So when I type this 5 in, it is replacing that x with that root. So I can type a 4 to do a fourth root. You can type a 3 to do a cube root, but it actually has a cube root button if you look in there as well. And then you go ahead and then type in your negative 32,768, and it'll tell you that answer is negative 8. Okay, so both of them are the same. It's just which order I'm doing finding the root and which order I'm finding the exponent. So this way, a lot more calculator work. Most of the time this way, I can kind of do that in my head. So I'm going to always do that because I can be faster that way. So up to you. Both are correct. Both will get you to the correct answer. All right, you might have a problem that would have a negative exponent. All right, so then we have to go back to our exponent rules. We're not going to leave any negative exponents. So I will do the reciprocal. And now I have a positive exponent. So notice I did not flip over my 3/2 power. We have never flipped the exponent over, right? If that was just 1 over, oops. If that was just 36 to the negative second, I do 1 over 36 to the second. I don't change that to the 1/2 power. You didn't really know the 1/2 power existed. So don't create new rules that we have done. All right. Okay, so over here, now let's think of that as the square root of 36 to the third power, or the square root of 36, and I'm raising that 36 to the third power. So once again, I like this method up top better because I'm going to take the square root of 36, which is 6, raise it to the third power, and so I have 1 over 216. Math Excel will want you to write your answer as a simplified fraction. Okay, over here, I would have had to take 36 to the third power, which I would need a calculator for, and so that would give me 46,656, and then I'll need to take the square root of that to come up with my 1 over 216. Both the same answer, whichever way makes more sense to you, up to you. All right, so no negative exponents will be left in your answer, no fraction exponents left in your answer. Okay, simplify any fractions that you have. All right, let's try another one. So if I have 2 to the 1/2 times 8 to the 1/2 power. All right, so I can convert this to 1/2 power means a square root. So square root of 2 times square root of 8. Since they are both square roots, I can multiply those together to get the square root of 16 is 4. And that would be my final answer. If you notice that these do have the same exponents, if they have the same exponents, you are allowed to multiply their bases. All right, so I also could have written that as, well, 2 times 8 would give me 16 to the 1/2 power. I did not change the 1/2, I just multiplied their exponents together, and then that would give me 4. Okay, a couple other things that you'll have to do, you will need to just switch them from one form to another. So a lot of students will kind of look at this, the problems that we just did, they're all numerical. And they might say, well, I can plug all this in my calculator. Why does it matter if I know how to switch the forms? Well, obviously in algebra, we're not always just going to use numbers. We'll have some things with variables as well. So we will need to know how to do this by hand. All right, so we might have to write the expression in radical form. So I have 2x to the 3/5 power. Okay, I'm not simplifying really anything with this. I don't know what x is, but I'm going to write just the radical expression. Okay, 5 is going to tell me the index. 3 is going to tell me the power. All right, and notice that x is the only thing being raised to that power. 2 is not being raised to that power because it doesn't have parentheses around it. 2 is just to the first power. So make sure your 2 is not inside of your radical because it's not being raised to that fraction exponent. Since 5 is on the bottom, that is my index. 3 is on top, so I'm raising x to the third power. Okay. So not really any work to show. It's just the knowledge of that rational exponent. Another example like that, I have y to the -5 halves. Once again, we have a negative exponent. We will not leave any negative exponents. So I'm first going to take care of that. So y would go to the bottom so that I have a positive exponent. It's still 5 on top, 2 on the bottom. If 5's on top, that's going to be my power. If 2's on the bottom, that's going to be my index or my type of root that I'm using. So I'll convert that. So I will have the square root of y to the 5th. Now, I've always made students rationalize this and not leave the radical in the bottom. I was looking at Math Excel, and they have left these problems with the radical in the bottom, but they did simplify inside the radical. So I'll just do that so that you are being consistent with how you should be typing in your answers. All right, so I have y to the 5th power. If I'm taking the square root, a couple different ways you can think of that. If you recall from a few weeks prior here, this means a 2. So I can take 2, goes into 5, 2 times evenly with 1 left over. All right, that's your logical kind of mental math process. You could also break this into y to the 4th times y. If I take the square root of y to the 4th, I get y to the 2nd, and I leave y inside. Or we could write y squared times y squared times y. Square root of y squared is y. Square root of this y squared is y. I have to leave that y. There's my y squared and y. So this is how they're going to want you to type that answer in for Math Excel. So simplify all your radicals. You can leave the radical in the bottom. We cannot leave any negative exponents. Okay. All right, moving on to a couple different types of examples here. We are going to write the expression with exponents. So we kind of got to do the reverse. We are going to be given the radical expression. Then we're going to rewrite with the exponents. So I've got the square root of 6x to the 7th. No simplifying, I'm just rewriting this. Okay, so that means square root, no numbers listed, so 2 is going to be the denominator. I need to look at what each different thing inside of my radical is being raised to. The x is being raised to the 7th power. The 6 is not. 6 would be to the first power. So 6 is to the first power, but it's under a square root. X is to the 7th power, but it's under a square root. And that's all we're doing, just rewriting with those exponents. Okay, another example like that. I have the cube root of 3x in parentheses raised to the 4th power. Okay, now the one above, it was not in parentheses. This is in parentheses, so that means both the 3 and the x are being raised to the 4th power. And both of them are under the cube root, so both of them will need 3 as their denominator in that rational exponent. All right, 2 more examples and we're done. So we'll go back to simplifying. You might get something like the cube root of x times the square root of x. All right, and this always throws students off. They're not sure what to do with this. Many of them want to multiply x and x together and get x squared. But the problem is I have a cube root and I have a square root. So what kind of root would you put over that x squared? You could not do that since they are different roots. So then they kind of get stuck. All right, so what we need to do here is I want to change this to a form we just learned and we just practiced. I want to change this to its exponent form. Okay. Now I'm still not allowed to multiply x and x together because they have different exponents. If you think back to that example, we had 2 to the 1/2 times 8 to the 1/2. I multiplied the 2 and the 8 together because they had matching exponents. That is not what I have here, so don't get those mixed up. Okay, what I have here is I have the same base. So when you have the same base, what can I do with those exponents? You can add those exponents. If you remember last quarter, I had you do some problems and some practice on one Friday with exponent rules, with negative exponents, it's coming back to us now, and with when we add and subtract our exponents with the same base. Okay, so that means I need to add 1/3 and 1/2. Going back to when you're adding fractions, I need a common denominator. So my common denominator would be 6. So I multiply by 2 and 2, 3 and 3. So 2 6 plus 3 6. Keep your denominator the same. Add across the top. 5 6 is going to be the exponent on x. Okay, I did not change the base for x, just like I didn't change the base here. I believe most of the problems want you to put it back in that radical form, so this is technically correct, but the 6th root of x to the 5th, I believe, is how I've been seeing it asked in Math Excel. So make sure you pay attention to that little note on how it wants you to write it for a final answer. Okay, one last problem. Pretty similar to what we just did above, but now instead of multiplying, we will look at division. So the 6th root of 2 over the cube root of 2. Okay, very similar situation. I can't divide those 2's. I don't get 1 because I have different roots on the top and the bottom. I have a 6th root and a cube root. I cannot do any division. The only thing I can do is change them to their exponent form. And if and only if the 2, I have the same base, then I can use some exponent rules. Remember, when you are dividing, I subtract those exponents if they have the same base. So 2 is the same base. So I'm going to take 1/6 minus 1/3. Once again, we need common denominators to subtract. So I will have to multiply this by 2. So I get that common denominator of 6. So 1/6 minus 2/6 would give me negative 1/6. So that is my exponent on my base of 2. Okay, we're not going to leave a negative exponent, remember. So that means I'll put 1 over 2 to the 1/6 power. I will convert that then to its radical form, the 6th root of 2. Typically, we don't leave the radical in the bottom, but the problems in Math Excel, I noticed, did. So that will be your final answer that you would type into Math Excel. Okay, that is our lesson for 6.4. Please reach out to me if you have more questions in working through your homework.